Assalamualaikum and greetings to our lecturer, Dr. Farah Yasmin, Binti Abdul Rahman, and also my fellow friends. And today, I will show you on my progress on Lab 1 about assembly language programming on data transfer, data processing, and addressing modes. And without further ado, I will show you on the exercise part. Alright, in the question 1, we are given a task to write a program that will store 0x30 into R0, 0xabcd into R1, but there is an error in this statement, which should be R2 here, and 0x1295a f90 into R3. And next, copy the content of R2 into R9. And also, this is have a little error here where it should be it's true, but R2 into R9, just this here. And this line here, I guess there is no info on this. And R0 into R11 is remaining the same. Execute the program and explain the differences in the result. Also, discuss the data size and addressing modes used. Alright, let's go on the kill software. First, we need to this thing. No. Question number 1 and remove file number 2 first, and let's go to number 1. Alright, as the instruction for the number 1, I do as like here, and let's go on the debug mode. Alright, for the question 1, we are given to store the R0 with the value of 0x30, but the data size for 0x30 is the size of 8 bytes, which is need the instruction of MOV, which is the size of maximum 0xFF. And for the second value is the 0xabcd into R2, and the ABCD data size of is in half word around 4 bytes, if I'm not mistaken. And sorry, and 30 is, if I'm not mistaken, is 2 bytes for the data size. And for 4 bytes of data size, we use MOVW for the half word. And for the register for the R3, we use LDR to insert the value of constant of 0x1295a f90 into the R3, because the data size is the size of 8 bytes. Alright, the addressing mode for the line 7, 8, and 9 is most of immediate data, because the register is being inserted by a constant value. And next, first let execute the code first. Sorry. Number 1. So as you can see, zero error there. Alright, sorry for the inconvenience. Alright, first we start with the MOV line, which is in the 7th line. So after we execute, the value before that, we set the initial value for each register is 0, and after the MOV instruction is being executed, the value of R0 become 0x00000030. And next, for the next line, the R2 being inserted with value of 0x abcd. And for the next line, the R3 is being filled with 0x1295a f90. Alright. For the next line, we use addressing mode of mixed addressing, which is we do a process with the consist of two register, where the Rn should the content of Rn should be processed into the Rd, which is the register of the destination. Alright, let's execute the line 10, and in the line 10, the content of R2 is being copied into R9, and before the 10 line is executed, the R9 is 0, and after the line MOV is being executed, the R9 become 0 x abcd, which is the content of R2, and after that, the content of R0 is be copied into R11. And now we close it, and the condition for the question 1 is fulfilled. And next, let's go to the second question. And now for question 2, we need to write a program that will store data 0x2233 into memory location of 0x4004 000. Oh, there should be 10 here, and 0x4578a90b into memory location of 0x4004 Then copy content in memory location of 0x4004 until 0x4004 into R0, and content in 0x4004 into R1. So execute the program and explain the differences in the result. Also discuss the data size and addressing modes used. Alright, from this situation, we know that we need to store data of 0x223 into location of memory in 0x4004 and also we need to store a new value of 0x4578a90b into memory location of 0x4004 and after that we copy the location of the memory from 4004 0001 until 4004 0004 into R0. And also we need to copy of this address into R1. Alright, let's go for the coding. Alright, this is the coding that I interpret from the question. And first we build it first before I explain it. Alright. Alright, first for the line 7, 8 and also 10, we use to initialize the data, and the data size for the R2, which is the beginning of MOVW, is the size of 4 bytes, and for R3 is 8 bytes, and also for R4 is also 8 bytes. But for the R2 is the value itself, and R3 is the points to refer the address of the memory. Alright, let's go into the cursor line of the beginning of the main. Alright, as you can see for this line, all the register are we set as 0. And let's go for the next line. The value of 2233 is being inserted, and also the value of address point of 40040000 into the R3. Oh yeah, before for the strh, we use this instruction to store the content of R2 into the memory of R3, which is the address of here, value here. Sorry. Because of R2 is the value of equal to half word, we use h after the str to store the content of the register into the memory. And for the 10 line, the value of 0x4578A90B is being inserted into R4. Next line. Oh yeah, I almost forgot. Right. I almost forgot. Alright, number 2, movie, cursor line, 1, 2, 3. Alright. For the line 9, we store the content of R2 into R3, right? So in the memory itself, the value before this for 0404004 before the value of R2 is insert is 0000, and after the content of R2 is being copied into the address of R3, it's become 3322. And because of the STM for our study is using the little endian method, so the LSB will be inserted first, and followed by the next value of LSB. Sorry, for the followed by another number of MSB, and for the next line, right, this we know that the value of R4 is fixated by this value. Alright, for the 11.9, the data from the R4 itself is being inserted into the address of the memory R3, but I'm using a shift method to insert the value of R4 into the memory. So before that, this point here started from the LSB from the R4 because of the use little endian method. The LSB is inserted first in the earlier addresses, and the MSB is being inserted in the for the last or the highest value of addresses in the memory. And for the next line, which is the 12th line, we need to transfer back the the value from the memory started from 0 for 004 0001 until for 004 0004, if I'm not mistaken. Yeah, that's right. So because of the places for the addresses for the addresses needed, I decided to use LDR instruction because the total of the places in the memory is the same as the value of 8 bytes. So we call the value into R0 from R3 using LDR. So before this, R0 is not being used, so the value before that is 0. And after the line is executed, the value of R0 is changed from 0 into 78A90B22. Because of the use little endian methods, the LSB is being inserted to the right or to the LSB part first, and the MSB part is inserted for the highest number of address. And for the next last line, the content of R3 is being copied into register 1. This is the size of the data is 2 bytes, which is 8 bits. So we just need an instruction of LDRB only to transfer the content of memory into the register. Yes, that's all for question 2. Let's move to question 3. In question 3, we need to write and execute a program that will add value of 0x20FE5690, 0xFE123089, and 0x34589 710. And the and of the sum must be in the register 7 and record the changes in CPSR. Alright, first we know that the process of addition is happen in this question, and the addition process is between of the three value. This is this value, and the ends must be in register in R7. Alright, let's go into the kill software. Alright, first we must initialize the three value into the registers, and I put the three values in the R0, R1 and R2. First, let's run the program first. Alright, 0 error. Number 3. Alright. Alright, as we show there, R0, R1 and R2, we set it as 0 or reset, and after we execute line 7 until line 9, the three value has been inserted into the register R0, R1 and R2. And next, addition process is happen, right, in 10 line. In 10 line, this is the result of the summation. For the changes in CPSR, only C is changed into 1 because F, the value of F plus 3, they have carry in the fifth bits of the MSB. So because of that, they changes the value of C, which is the carry. And for the negative value, it's not changes because the total of the summation is of in the binary of 0001. Because of the MSB of the given binary is 0, the n is equal to 0. And for the Z flag, they are 0 because they have value in the R3. And for overflow flag, which is V, is 0 because they have both both value in the bit 5 and bit 4 of the bit during the summation. And let's proceed for the second addition. As in the result, the summation is as in the R7, which is 0x5369 1e29. The carry is turned into 0 because of the total summation doesn't produce any carry in the fifth bits of the MSB. Alright, and now all of the codes is answer the question 3. For question 4, we are asked to write a program that will store 0x2936 FEDA in R8 and then perform the following instruction on the content of that register 3 times. Comment on your result for first Roman ASR, second Roman LSLS, and the third Roman's RORS. Before executing the program, set initial value of C flag equal to 1. Alright, first thing first, we know that we need to initialize the value of the hexa value into R8 and perform the shift instruction of ASR, LSLS, RORS for 3 times in the coding. So let's go with the ASR first. Like for the SR, I do it like this, and we run program since there is no error. No, this is number 1 and number 4 first Roman, which is we need to execute using ASR shift instruction. So as we can see, the array is loaded by the value given, and the value in R7 is different between the and sorry, I forgot to set initial of the CPSR into equal to 1. Sorry for the inconvenience. Number 4. Alright. C equal to 1. Enter. Alright. Now the carry is be set equal to 1. Let's execute. Right. The R8 is loaded, and the R7 is the destination register for the process of ASR R8 for 3 times, which is the arithmetic shift right, where the the bit is being shifted to the right by 3 times, and the remaining of the space in the MSB, because they shifted to the right, is being extended by the which is extended by the value of the latest MSB. And for this, the value is 0, because the MSB is here too. So if we expand the bytes here, the 2, which is the 0 0 1 0, if the number 0 0 1 0 is being expand into to the right, and the space left that has been empty there is being filled by the MSB of this register. So because of the MSB is 0, so we fill the empty space with the number of 0. So since there is no carry inserted in the carry part because of there is no S signs here after the R's. So the instruction here is not affected the CPSR. Right. Next we go to Romans. Please give me a few moments. I need to call the file. Right, adds, and this we need to remove for 2. All right. Zero error. And actually the first Roman and second Roman are the same, just the shift instruction only the difference between them. So first thing first, we need to set this as 1. All right, and now we run to cursor. So wait, sorry, why? For 2 ASM is true. For 2 build target 1 0 error, and here is on. All right, for 2 LS. All right, nice. Top. Right, first set to 1. Okay, let's execute. Next steps, and now the value is being filled into R8, and now left shift, this is happens here where the bits of this R8 is being shifted to the left, and the empty space on the LSB is being replaced by zeros, zero fields, because of what I say there, because the value of A from hexa into binary is 1100, and because they are not affected by the LSB or the MSB, the instruction of LSLS is only replace the empty space with zero fields. And next, the CPSR, since the instruction is include of S, they may be affected the carry, but the carry is remain the same because of LSLS is the location of for the carry of the recent is 0, because the R8 is 2 0 0 1 0 is being shifted, and the value of C is remaining to 1 because the third from the left or from the MSB of R8 is 1, where the 2 of the number hexa is when being converted into binary is 0 0 1 0, and the value of ones there is being shifted to the left by 3 value, and because of they being shifted, the value of 1 is being transferred into the carry part. That's why the value C is 1. Right. let's go for the third Roman. Existing file. Sorry for the waiting. For 3, add, close, remove file. For 3, okay, sign here to build zero warning. Zero error, and we run the program. Number 3, cursor to line, and CPSR is set to 1. Alright, then next is the same as process, which initialize the R8 with the value given, and now we execute the the instruction of RORS, which is rotate orientation shifting, which the process is shifted the value of the register to the right, but at the same time the value that's from the LSB after the shifting will be inserted back into the MSB part. The value of LSB will be inserted into the MSB after the shifting. Alright. So as you can see, the result as in the R7, which is for 526 DFDB, and for the CPSR C equal to 0, because of the third bit from the right, which is A1100, which is the value of 1 is 1100 is be shifted to the right, and after the shifting process is done, the one that has in the 1100 is being inserted into the carry, and also the number 1 of the 1100 from the right, the first from the right one is also inserted in the MSB, because the process of the shifting of it from the carry and into the MSB is simultaneously. Alright. I guess that's all for question 4, and next question 5. Alright, for the last question, which is question 5, we need to write a program that will perform logical OR 0 between 0x6398 with 0x1 DFE, and next the program perform logical XOR on data 0xa1 b3 for 690 with 0x1389 for b5c. Execute the program and comment on the result. So for the question 5, logical process is happens there, and without further waiting, let's go for the coding. Alright, for the exercise 5, I interpret it like this, which is first, we need to initialize both value that needs to be executed with ORR instruction, which is the O gates one, and we just need to run zero error and debug mode. Question 5 there. Run to cursor line. So for the second line, they just initialize the both value into R1 and R0, and for the line 9, the result is as below, which is 7FFE for the result, because we just take example for the 6 and 1. 6 in binary is 0 1 1 0, and for the 1 is 0 0 0 1, which is 1 1 0 0 will be compared with all logical process or logical gates with or function, which the value that when the one of them have become true or 1, the result is end with 1, and also if both of them get result of 1 for both value, and also the result with end with 1. And for the example as before, 6 0 1 1 0 and 1 1 1 0, which is from the MSB 0 1, which there was one of them is true or 1 value, so the OR gates process will make the if one of them is 1, so the result is true and it will get 1. And for the next process, we move to XOR, and first thing first, we initialize the value of both value given in the question in the R3 and R4, and we execute the program. For XOR, we using EOR because it is specific for the exclusive OR gates itself, and the result is being inserted in R5, which is B23A0DCC. Alright, from this view, we take for example is 4 here and 4 here. We know that for value of 4 in binary is 0 1 0 0, right? So because of exclusive OR gates, even if both value comes with like this, for R4 is 0 and for R5 is 0, and also the result is 0 because of the exclusive OR. But also exclusive OR execute when becomes 0 because of both register have the same value as in hexa 4 and for the R3, and also hexa 4 with R4, which is the value of 1 in the R4 side, and also the value of 1 in R5 side. which is when the process of exclusive or for the both value which will get for zero value. Alright, because of the question never asked for the CPSR, we assume that the instruction S is not important. It's not like it's not a major in this question, so we just ignore it and we execute if in normal ways without the S. Alright, I think that's all for the last question, and also I think that's all for my presentation on the exercises and also progress of my coding, except for this lab one. And thank you for watching. And also selamat berhari raya.